Hello everyone. On behalf of the Victorian team at the Institute of Architects, I'd like to offer you a warm welcome to today's Lean-In, where we'll be looking at designing for climate emergency. My name is Stephanie Bullock and I'm from Cosloff Architecture and sit on the Institute's Victorian Chapter Council, and it's my honour to be your host and moderator for today's Lean-In session. We're joining from across the country today. We acknowledge with deep respect the traditional owners of this land and also acknowledge that it is a privilege to stand on country and walk in the footsteps of those before us, and we pay our respects to elders past, present and emerging. Today's Lean-In session is being recorded, so if you miss anything today or have to leave early, we'll be publishing this recording on the Institute's YouTube channel in the next couple of days, and we will share that link with you in our upcoming email communications. This Lean-In session enables you to ask questions of our panellists. So if you have a question or a comment, please use the Q&A box down the bottom of your screen to add yours in, and we'll go through these with the panellists at the end of the session. So today's session features two panellists. Dr. Aysu Kuru is an architectural designer, sustainable building engineer and lecturer in architecture and construction at the University of Sydney. Aysu's experience is focused on environmentally sustainable and regenerative design, building performance assessment, and architecture for climate change. Dr. Malay Dave is an associate at Steenson Varning, who enjoys design and innovation challenges that accompany his role as a strategic sustainability advisor. With a background in architecture and sustainable development, he is passionate about and inspired to research, design, and create high-performing, resilient, and regenerative systems, places, and communities. Aysu and Malay, welcome to our Lean-In. It's great to have you with us.
Thank you, Stephanie, and welcome everyone to Malay Dave's and my presentation on designing for climate emergency in this Lean-In session. Next slide, please. Before we begin, I would like to acknowledge and pay respect to the traditional owners of the land on which I join you, the Gadigal people of the Eora Nation. As we share our own knowledge and practices, we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. Next, please. The agenda of my part of the presentation includes three main themes: climate and biodiversity crisis, research-driven projects for climate emergency that my colleagues and I undertake, climate and nature action. Next, please. We often talk about climate change, but I rather call it climate emergency to emphasize the need for urgent action to halt climate change. Next, please. And let me better describe what climate emergency means. Climate emergency is a situation in which urgent action is required to reduce or halt climate change and avoid potentially irreversible environmental damage resulting from it. Next, please. Well, an architect finds comfort in visual representations, and here is a visual representation of the impact of climate change on the global temperature increase. It's called Show Your Stripes, an illustration that can be generated for the whole world or specifically for places to show the temperature of each and every year since 1850s in colored stripes. Blue stripes represent colder temperatures and red stripes represent warmer temperatures. Over a century between 1850s up to 1950s, we've mostly had blue stripes. Between 1980s and 2010, we started to see the red stripes more frequently. And since then to date, the stripes are now dark red. This reinforces the urgency of global warming. Next, please. And the climate conferences that's been held since 1979 seem not to help that much, including the Paris Agreement, in which many countries agreed to limit global warming to 2 Celsius degrees. Next slide, please. We talk about the climate crisis often, but how about the biodiversity crisis? Have you heard of or seen the biodiversity stripes instead? Well, here they are, showing the global decrease in biodiversity since 1970s until 2018. Next, please. This is the case for the climate crisis and biodiversity crisis, but the picture is bigger than this. Human life is practically possible within what is called the Holocene state of Earth. Human life may not exist beyond the boundaries of the Holocene state, which are called the planetary boundaries. The boundaries consist of 9 global processes In 2009, 2 boundaries were already crossed, while others were in imminent danger of being crossed. Later estimates indicated that 3 of these boundaries, climate change, biodiversity loss, and biogeochemical flow boundary, appear to have been crossed too. Next, please. That is what's happening globally, but this story is no different in Australia. We have crossed 5 of the 9 planetary boundaries which we have information about, and the other 4 remain a question. The icons on each slice of the chart shows the limit at which we are for that planetary boundary in Australia, from safe, which none of them are, to approaching limits in yellow and transgressed in orange. Next, please. This results in a threat to nature in Australia. In fact, 19 ecosystems all around Australia, as illustrated on this map, may never recover from the loss they have experienced. Biodiversity is under threat and nature is being destroyed. Since 2020, the global human-made mass exceeded the biomass found on Earth, which means that humans built more within their lifetime than what nature has over millions of years. Next, please. Buildings' contribution to both the climate and biodiversity crises have been measured to be extensive. Globally, buildings emit almost 37% of greenhouse gas emissions. In Australia, this figure is 1/5 of all emissions. The problem is carbon emissions is maybe half of the story. Humans' ecological footprint, shown in the blue donut chart, which is based on human activities and land use, indicates the human demand on natural capital. Carbon footprint is only 60% of our ecological footprint. So if we only address carbon, we will just do a bit more than half of the impact we have on Earth. Buildings' contribution to the ecological footprint is yet to be clarified and measured. Next, please. Australia is identified as one of the most vulnerable developed nations to climate change. There is increasing evidence of climate change interacting with underlying natural variability and resulting in substantial increases in the frequency and intensity of extreme weather events, as we all have experienced in Australia. However, there is an opportunity rising from this problem that is the transition to a net zero carbon economy. Australia has the capacity in terms of technology and available land to not only transition to, but become a world leader in a zero carbon economy. Next, please. That's it for the problems we face in terms of climate emergency, and now I'll move on to talking about the solutions. First, I'd like to introduce a science-based study me and my colleagues have undertaken at the CRC for Low Carbon Living, which is the development of a climate emergency design guideline for Australia to race to net zero. Next, please. In this climate emergency guideline, we looked at the whole life carbon performance of various building archetypes across all Australian climate zones. We identified carbon emission sources and reduction strategies in buildings to achieve net zero carbon performance for carbon neutrality. Some of the emitting sources include heating, cooling, manufacturing, lighting, transportation, materials, hot water, construction, demolition, appliances, maintenance and disposal. Some of the reducing strategies include recycling, renewable energy, low carbon supply chain, energy efficient design, dematerialization and carbon offsets. Next slide, please. We mapped the potential of carbon reducing strategies in various building types and the potential for generating renewable energy to offset operational carbon to reach net zero operational carbon performance. We set a net zero target for 2030 in alignment with the urgency that climate change requires. The graph here shows our suggestion for delivering on the net zero operational carbon for commercial buildings as a step-by-step emission reduction and offset pathway by 2030. Next slide, please. We also mapped the potential of embodied carbon reduction strategies based on the architectural project's timeline from master planning to conceptual design, detailed design, and all the way to construction documentation. The embodied carbon reduction strategies to achieve net zero performance can be categorized under 4 items. First, do not build, and if that's not an option, Adaptive reuse may be one. Second, build less and dematerialize. Third, build smarter and optimize. Fourth, use low carbon supply chains. Next, please. Achieving net zero whole life carbon performance is often a pathway, a journey. As such, we map our climate emergency design guide, similar to a journey too, as you can see on this slide. But the difference is that it comes with milestones to meet at various timeframes. Based on our calculations for the Australian building sector to reach net zero by 2050, operational carbon can be net zero by 2030 and embodied carbon by 2040 for new buildings. And the existing buildings can achieve net zero carbon performance by 2050 altogether. Next, please. Now I'd like to move on to a second research-driven project called Ecoactive Building Envelopes. Ecoactive building envelopes is an innovative concept of designing building envelopes that give back to the natural ecosystems that they're a part of. So they do not only offset their emissions, but they give more than they take from the environment. As such, they're also named negative emission technologies. Next, please. Ecoactive building envelopes can respond to many aspects of the environment, including the sun, wind, air, and they make use of these resources. How they do it is based on applying nanotechnologies onto the building facade and roof. There are nanotechnologies being developed at the University of Sydney Nano Institute. Some of the ones we identified as suitable for building application include nano-radiative cooling, nano water harvesting coating, metal organic frameworks that capture carbon from the air, and food production through living materials. Next, please. To enable the application and adoption of nanotech in buildings, we've teamed up with a lot of researchers within Sydney Nano across the disciplines of architecture, science, and engineering. Here are all the multidisciplinary collaborators on this project. We currently are building a one-to-one scale prototype of an ecoactive building envelope using our core research facilities at the University of Sydney. Next, please. In particular, the nanotechnologies included in the one-to-one scale prototype are atmospheric carbon capture, algae bioreactors, and nanotech photovoltaics. The carbon capture technology emits carbon from the air. This is an important technology because it helps to get rid of the carbon dioxide that is already in the atmosphere. This is known as carbon sequestration that trees do, but with carbon capturing nanotech, we can do the same in a rapid fashion in support of living things absorbing carbon dioxide. Think this like making buildings carbon sinks. We couple the carbon capturing nanotech in our prototype with an algae bioreactor. Algae bioreactor is essentially a transparent system that can be implemented on the facade. Algae is a living system and it needs carbon dioxide to survive. The carbon captured by the nanotech using our prototype is then given to the algae to be turned into oxygen by the algae. So the prototype is a negative emission closed loop system. There also is a photovoltaic system helping generate green electricity within the prototype to offset the energy used for the carbon capturing nanotech technology. Next, please. Well, that's enough talking technical. Now we'll zoom out and talk about climate action to tackle climate change. Next, please. The Australian and state governments are on track to reach net zero emissions by 2050. Some states have already achieved this, and some have more ambitious targets than the federal government. But what matters is that Australia is aware and committing to make an impact. Next, please. We've talked a bit about climate conferences, but not mentioned the biodiversity conference. Similar to the climate change conference of parties, which stands for COP, there is the Biodiversity Conference of Parties, or Biodiversity COP. The last one was held in December 2022 with a significant outcome. Something like the Paris Agreement of Biodiversity happened in that COP15 of December 2022. More than 90 countries committed to reverse nature destruction by 2030. In doing so, they committed to protect 30% of land globally. Australia committed to this pledge too, not necessarily protecting the land at home, but globally altogether. Hopefully this will be followed by national action to protect land at home too. Next, please. Where I work, the University of Sydney is committed to take action on climate as well. I find it motivating to give you some insight into the University of Sydney sustainability strategy in the hopes that it can inspire other organisations like where you may be practicing. At the University of Sydney, we're committed to send zero waste to landfill, reduce water use by 30%, have less than 10% of staff to travel to campus by private vehicles, promote our sustainability research by living labs, showcasing our research across our campuses to raise awareness, foreground Indigenous knowledge in all our sustainability work, and expand our multidisciplinary education offerings on sustainable design. Next, please. The University of Sydney is fully powered by renewable sources since July of last year, 2022, which is quite promising. Next, please. At the School of Architecture, Design and Planning, we declared climate emergency last November in 2022 to acknowledge, map, and expand our research, teaching, and operations relating to sustainability for climate action. Next, please. And not just at the University of Sydney, but all together as the citizens of the world, our common goal must be to zero net loss of nature at least. As I highlighted earlier, human-made mass exceeded biomass in 2020. We can reverse this in a decade if we act together to deliver on climate and biodiversity emergencies. And by 2050, we can achieve more than a full recovery of nature and become nature positive. Next, please. I'll leave my details here for anyone who wishes to connect and leave the microphone to my colleague, Dr. Malay Dave. Thank you for listening.
Hello, everyone. Before I begin, I would like to pay my respect to the Gadigal people of the Eora Nation, where I officially work from in Sydney, but also to the Larrakia country where I'm residing at the moment. I pay my respects to elders past, present, and emerging. My presentation is divided in 3 distinct parts. First, I would like to talk a bit about us and our climate actions in continuation of Aysu's presentation. Then we will quickly get to the point on what we need to do and how we might be able to do it. Present a case study of a project that we are working on currently, and then might discuss on how we might go beyond the point, what that might be, and a case study talking on that going beyond. A bit about ourselves. Stinson Warming. We are practitioners in mechanical, electrical engineering, lighting, and sustainable designs that enhance spatial design. One of the key principles for us is to create positive environments. Our company was set up in 1933, and we came to Sydney, Australia in 1973, working on this project that's on our screen. Ian Warming was an accomplished cello player who was the lead engineer on this project. Since then, we have continued to work on this project and many other iconic projects in Australia and internationally through our 5 global studios. In terms of environmental sustainability and commitment to climate and society, we have been early adopters and early signatories of United Nations Global Compact. This includes 10 principles divided into 4 key categories, covering human rights, labor, environment, and anti-corruption. We have expanded our attempt for positive impact beyond this. Recently, we have been assessed on B Corp assessment. B Corp stands for Benefit Corporation, where organizations' actions in their day-to-day operation provide beneficial contribution to the environment and society at large. We were very pleased to find that our overall B impact score was 104. 50 is the median score for ordinary businesses, and 80 is the minimum score to be eligible for B Corp certification. This was our first attempt, and we will continue to work on enhancing and expanding our reach in 5 key categories, which are rigorously assessed and independently verified through B Corporation. These 5 categories are governance, workers, community, environment, and customers. I'm very pleased to say that our company is, in most cases, significantly above average for the country or the sector. Just as a snapshot, one key category, environment. This shows the overall scope of the assessment. It is fairly comprehensive and very rigorous assessment. In terms of environment, it looks at environmental management issues, air and climate, water, land and life, training and collaboration, and the type of impact the business model itself makes, community, the impact that business makes, impact on, certifications, what type of certifications building the business is engaged with, and materials and codes, other types of impact in the materials category. In addition to those, we are also certified with ISO 14001. In addition to declaring climate and biodiversity emergency, being signatories and participants in City Switch and being awarded by that program in Sydney. We have recently engaged with UN Global Compact's Climate Ambition Accelerator, which is a 6-month intensive program to help set up ambitious emission reduction targets based on science-based targets. So we are just embarking on that journey. So far, we have been able to tackle our scope 1 and 2 emissions of our organization substantially, and we believe we are already in the territory of net zero. We have set a target for ourselves by the end of this year, 2023, to be carbon neutral through climate active carbon neutral certification. So that's just a little bit about ourselves, demonstrating our passion for walking the talk on climate emergency. But it's important that we all get to the point very quickly. And the point being, we need to get to the point where we can say we have reached net zero. Aysu's presentation has already demonstrated the level of urgency we are dealing with. Time is of the essence, and the substantial reduction that we need to make is also very critical. This simple graph from Science Based Targets Initiative very simply illustrates the enormous task ahead of us. Essentially, every project and organization across all its scopes of emissions will need to reach net zero by a certain timeline. By most agreed timelines, it is 2050. The hatched bar at the top demonstrates the reduction in emissions that is required as much as possible. There will inevitably be a portion of carbon that will not be able to be reduced through elimination or reduction in emission, and that will require neutralization or removal in the form of carbon offsets. This is based on our current understanding. The Global Carbon Project recently released their paper based on the remaining carbon budget, based on the latest IPCC report. And they demonstrate that we have 3 distinct pathways possible for that reduction to occur. If we were to stick with 1.5 degrees reduction, as per the Paris Climate Agreement, that reduction may need to be substantially rapid and acute than previously understood. This presents an enormous challenge, but something that we have the capacity and technology to deal with right now. I would like to start the second part of my presentation in this context with a question that was raised by one master long time ago. Le Corbusier asked, "It is a question of building which is at the root of the social unrest of today, architecture or revolution?" If the master was today to see the climate emergency we are dealing with, he might say it is a question of building which is at the root of the climate emergency today. What do we want to produce, architecture or revolution? Leading organizations, whether they are practitioners or industry bodies, are taking a mission approach because of that need for revolution. This is just an example of Green Star Buildings tool from Australia that has taken a very robust approach for rapid reduction in carbon emission through the building sector. This is the climate positive pathway that was released as part of the new Green Star Buildings tool. This demonstrates the gradual ratcheting up of the stringency levels for Australian buildings. From 2020 up to 2030, increasingly at every 3 years, the buildings are required to improve their performance through minimum performance stringency increases across 4 key categories that are essential for climate positive pathway. They are energy source, energy use, upfront carbon emissions, and then other carbon emissions that are not captured anywhere else. Presenting one case study as an example that we are working on right now has also taken a similar approach. This is a Melbourne Arts Precinct transformation project. This is the Yarra River, and on the south side of that is the Melbourne Arts Precinct. There are existing buildings, Hammer Hall, Theatres Building, the National Gallery of Victoria International. And there is a proposed building that also we are working on in parallel, National Gallery of Victoria Contemporary, or NGVC. It is very interesting to work on a project that has a scope for a precinct as well as individual building. It provides enormous opportunity in terms of achieving sustainability and high performance across different services and performance across different sustainability categories. It also presents several challenges of interface and complexity, how to deal with the performance assessment and delivering that high performance. What we started with was to set up an overarching sustainability strategy, a matrix. Across 10 different categories, we looked at various strategies, and as the project progresses through different stages, what strategies would apply and what we would consider and why. We considered sustainability management, site and environment, planning and microclimate, health and well-being, energy, water demand, transport, materials and waste, community and economy, and smart tech and infrastructure. We looked at high-level aspirations for the entire precinct and what that meant in terms of strategies. What would we consider at concept and master plan level or detailed design level? Infrastructure versus building design strategies, as well as after the completion of the construction, what would be the ongoing strategies for future phases for operation and post-occupancy? This shows that sustainability and climate emergency was taken quite seriously and applied quite comprehensively. Without going into much detail on all different categories, I would like to focus on the key aspiration of the project, which is aiming for zero. 5 categories were tackled in this aspiration: net zero carbon emissions from operational energy use, net zero operational water demand reduction in terms of potable water, waste reduction to zero or avoiding waste diversion from landfill, which would include demolition, construction, and operational waste. In terms of materials, in addition to responsible materials and specification and environmental or human toxicity issues, we strongly focused on embodied carbon through A1 to A5 scope, which is upfront embodied carbon from materials, and transport in terms of net zero transport emissions from trips to and from this site. For each of these categories, we considered a hierarchical approach for decision making that required looking at the low-hanging fruit, biggest bang for the buck. For example, in terms of energy hierarchy, as you can see on the top left of this slide, starting at the high-level planning and street layout or the building form and massing, and then gradually zooming it down to the building envelope and system efficiencies to maximize the demand reduction for the energy and resultant carbon emissions. After that, offsetting the demand with the on-site generation and supplementing with renewable, whether on-site or off-site, and then having carbon offset as the last resort. Optimized network would be critical for a project like this, which has to deal with both precinct demands as well as individual building demands. Similar hierarchical approach was adopted for waste water transport and a circular economy approach for material selection and construction methodology application. At the master plan level, sustainability strategies, particularly when we focus on energy strategies, required considerations of the needs and demands of individual existing buildings and how that would relate to a new building proposed, which is NGVC, as well as all the space in between these buildings, which is the public realm, also being designed. The precinct design is being led by Hessel and a team of expert consultants, and we are leading, among other services, sustainability as well. What was proposed was a centralized system instead of a decentralized system for various benefits. Key benefits were energy sharing, improved redundancy and resilience of the entire system, possibility of future upgrades and maintenance, improving sustainability of the whole site as well as individual buildings in one integrated system, and the possibility of future improvement as well as eligibility of any grants available for renewable and district energy implementation. What was considered was an integrated resource management, considering both energy and waste and water. Here, we are looking at 2 key resources, energy and water. What will be available on site and what will be imported was considered. Vertically, you can see there are categories of general mechanisms that leverage this resource availability. There would be passive opportunities. What products would be required and processes will be engaged, and what would be the eventual output through each of those categories, and what would be the interaction across all these different systems, and how that integration will need to be included in design decision making was considered as a team. This is an example of an assessment criteria that was implemented for making design decisions. This is an indicative spread, a matrix. On the horizontal axis, this is various scores given based on performance levels. There are ESG performance levels and priorities considered, both in terms of resource efficiency of energy, water, and waste. Benefits to the community and ecology at large was considered. Resilience and redundancy aspects were considered as well. And in terms of practicality, cost, payback time, spatial implementation, and of course, disruption to a prominent site like this was also considered. Each strategy was assessed and given a score, and then that helped us compare all strategies with each other. A comparative analysis was able to demonstrate certain strategies were significantly more beneficial for a site and a project of this complexity, here shown in blue and green. And the red ones were unlikely to be feasible based on our assessment. For example, low temperature, heated, and chilled water network was considered much more beneficial to the project, and we are investigating further feasibility of that. Natural gas condensing boilers or trigeneration, for example, or high temperature chilled water network was considered not feasible for some of those criteria that I've just talked about. This process was very beneficial to demonstrate the decision-making rationale to the entire project team, and then bring everyone together for making a consensus decision on what was appropriate for the project. Through that exercise, we were able to compare various plant options available. On the left-hand side, we have the base case with existing plants and individual heat recovery chillers applied on individual buildings. This is an island mode or a decentralized system option. To the right-hand side, we see 5 different options, and each of those options were considered on those criteria previously mentioned. Through that assessment, in that early design stage, we were able to demonstrate that option 5 was able to provide significant benefit. Although this is a snapshot of a work in progress, and further considerations subsequently were taken into consideration, and the design process is still ongoing. However, this shows the method through which a decision-making process can be undertaken on a complex project like this. What was also considered was each option was compared based on 4 different other categories. Energy consumption for heating and cooling was compared for all those 6 options, or 5 options compared with 1 base case. Resultant carbon emissions from cooling and heating system was also compared. Water consumption for cooling was compared, and the net present value over 30 years. Based on this assessment, centralized system through a centralized services corridor was proposed and is being considered for implementation. As you can see in this diagram, existing street was elevated for a community garden landscape portal, under which there is a whole services corridor that runs and houses services spine. There is an energy center that will likely to be moved into the new building, NGVC, that drives this entire energy system for this entire precinct. Through this design and the options considered, it was found that the project was able to potentially achieve 52% reduction in heating cooling energy demand, 31% water reduction, and 47% reduction in CO2 emissions. There are other benefits also identified and further being considered. This is the services spine that I just mentioned about. Similar exercises are taken on all 5 categories: energy, water, waste, materials, and transport, and reduction potential was quantified. That quantification also was considered on individual buildings within the precinct, as well as through public realm in between those buildings. The project is still being designed, so this is a work in progress and will be further refined, fine-tuned, and optimized for improving this reduction potential. We also considered future climate impacts in that modeling, and we'll continue to model this in collaboration with other services consultants. I'm mindful that there is a dedicated presentation on resilience upcoming next month. So I will leave this particular aspect just here. NGVC, National Gallery of Victoria Contemporary, is the flagship sustainability project that will lead the sustainability of this entire precinct. At this stage, I'm not able to share a lot of the information of this project. Hopefully in the future, I may be able to. But it is safe to say that this project is going to lead sustainability through its architectural design and innovative systems that are being implemented. Aim for zero and the carbon neutral, climate active carbon neutral certification that applies to the entire precinct will also be driven by the high performance of NGV Contemporary. In summary, we found few lessons were very important to understand and share. One of the key ones is to acknowledge the complexity of a precinct project and how that interacts with individual buildings on site, whether existing or being proposed. It's important to understand individual needs and how they might need to be optimized, not just for now, but for future climate. Stakeholder engagement, not just beyond to the community and government bodies and clients, but also within the project teams and in between project teams, between architects and sustainability consultants and services engineers and so on, is critical for a project to tackle all the risks associated with projects like this. And there are many other benefits for this type of integrated design process that can be applied to other projects as well. I would like to present an example of an indicative net zero roadmap. This is not specific to any particular project, but this is an example of what we are considering on some of these projects that I've talked about. This shows the typical buildings, single-use buildings, carbon emissions from 3 different scopes, scope 1, 2, and 3, and a potential pathway for net zero. One of the first things that we would consider is emission reduction that would reduce the scope 2 emissions by substantially reducing the demand for energy. Fossil fuel-free energy is another key strategy that will eliminate scope 1 emissions from the site, and that would provide substantial reduction in overall. Below the horizontal line, you can see dotted line, that is the potential need for offsets without this substantial reduction. The more we continue to reduce the carbon footprint of the building through demand reduction, the more we are able to reduce the need for carbon offset. The third and the most critical aspect is 100% renewable energy. That removes the entire chunk of scope 2 emissions for an electrified building. When remaining carbon emissions from the waste and water, which are operational emissions and or associated with refrigerants, are eliminated through carbon offsets, a project can achieve carbon neutral certification in operation. This leaves the products and materials, the scope 3 emissions, the embodied carbon. The remaining embodied carbon through the embodied carbon reduction strategies after employed can be eliminated through carbon offsets, and a project can achieve net zero whole life carbon. And this is the point that we need to reach as fast as we can. An example of a reporting template is also worth sharing. It is part of our net zero carbon guide that Aysu mentioned, that we recently published. The purpose of this reporting guide is so that it can be available to all designers for communication as part of design teams and reporting the performance of their projects on operational carbon and embodied carbon both, and then relating their carbon status, tracking and communicating with the clients and disclosing where each project is performing. How good it would be if each of the projects applying for sustainability awards or design competitions would be required to fill out forms like this and disclose their carbon content. One more master comes to mind who said, "How much does your building weigh?" A question often used to challenge architects to consider how efficiently materials were used for the space enclosed. Buckminster Fuller was already talking about the environmental impact of buildings. Today, he might tweak this quote, this question, and might say, "How much does your building weigh in carbon?" Probably we need to ponder on this question, because that is the one that will take us to the point. But it is critical that we go beyond that point as well. What I mean by that is the point of net zero, or the point of sustainability, as it is conventionally understood. We need to continue to push beyond the degenerating realm of sustainability from efficiency to sufficiency, going beyond that delicate accounting-based fragile net zero point onwards into the realm of resilience, into the realm of restorative, regenerative design and development. And that's where there is the future for our projects and increased responsibility for addressing climate emergency at the rapid rate that it asks us to respond to. Living Building Challenge is a globally recognized, one of the highest, if not the highest, stringency building and assessment framework. This has already taken the same idea about not focusing on negative environmental impact, but focusing on positive environmental impacts, going beyond zero, not limiting ourselves to doing less bad. It asks profound questions like, what does good look like? Two words are important here, good and look. And we need to define what that means. Good in terms of climate emergency and sustainability, society, regeneration of the whole system. We can also ask, what does good feel like? Can we ask these questions on each of our projects? Living Building Challenge also asks other similar interesting questions, questions that are not closed-ended questions, that won't lead us to an answer or a fact, but will make us think and lead us to that realm beyond that point. It asks, what if every single act of design and construction made the world a better place? Projects like what you can see here, Fifth Center for Sustainable Landscape, which is a living certified project, demonstrates what is possible. One such project that I've had privilege to be involved with is Narara Eco Village. It's a community project that is aimed to nurture a resilient and inclusive intergenerational community that is focused on regenerative environmental, social, and economic practices. This is just 1 hour north of Sydney. The project includes 64 hectares of land. 2/3 of it will be retained for conservation. Less than 1/3 will be used for development, including agriculture, bush regeneration, food co-ops, and other activities, and even less for housing, with a maximum of 100 houses in 2 stages at this stage. All houses are required to be minimum 7.5 star rating in the stage 2. Stage 1, which is just complete, required minimum 7-star rating. That was already beyond the minimum required by Measure star rating through National Construction Code, which is 6 stars. So this is already completed houses, which is more than 50, are on average 7.7 star houses. They vary from tiny homes to earthships to earth-backed construction, playful hobbit homes, to lightweight traditional construction, to hempcrete homes, or passively designed prefab homes, modular construction. The central home at the bottom is a hempcrete home, 8.8 stars with 11 kilowatt system, no heating or cooling system in the house. So these are the homes. Each home is required to have minimum 4 kilowatt PV system. In total, the village has 350 kilowatt installed power capacity. The village has a smart grid of 437 kilowatt hour community battery. This has been developed with funding and support from New South Wales government and ARENA. The entire community aspires to offset all its embodied carbon within the next 30 years. All homes are estimated to require 60% less heating and cooling than the average in the Central Coast region of New South Wales. At the moment, the entire Narara Eco Village exports at least 7 times the amount of energy it imports from the grid. So in terms of operational energy, it is 7 times positive. The grid provides its energy demand reduction as well as demand management and optimization and stability. Last 1 year, we have monitored its performance, and we have found that it's only in the peak winter the community was reliant on importing electricity from the grid to a small fraction. The rest of the time it was exporting. 88% of the time, this community was energy self-sufficient. Beyond that, beyond energy and emissions, there is a lot of bush regeneration and regenerative activities are also happening in this community. That leads me to the last slide of mine, sharing with you the last question that makes us ponder. We have now known what does good look like. The question now is how to make good real. The image you are seeing on the screen is a Living Roots bridge in the remote area developed by the local community in northeast of India. These are the bridges developed by living trees. They are developed over decades and they last for centuries. This is a living system, a bridge, a metaphor for where we have come from and where we need to go. What will take us? The other reality, the regenerative reality. I'd like to end with that question, how to make good real. Thank you.
Thank you so much for those presentations. They were brilliant, Aysu and Malay. We might run through a few questions, if that's all right, that have come through from the audience. So the first one is in relation to the grid and what happens after the point when it becomes 100% green or powered by renewable energy. And what does that mean for buildings with on-site renewables that are relying on those offsets to achieve net zero?
Thank you for the question. I think it is a good question and it is a good problem to have. Right now, we are so far away from it that probably if we don't want to think about that, that's fine. but we are rapidly changing the makeup of the grid. So the questionnaire is right to question that in some ways. By some estimates, by 2030, majority of the grid is likely to be based on renewables. There are opportunities for exporting that renewable energy as well. Not just internationally, which are, of course, in the pipeline, and industry organizations and industrialists are talking about that. We are only talking about buildings producing more energy than we need. The example I showed, Narara Eco-Village already produces this, and it does not get any monetary benefit because the feed-in tariff system is such that there is no monetary advantage of that. But we consider that it is a contribution to the greater society by pumping in that green electricity so that those that cannot afford can still benefit from that green electricity. That's one part of the answer. The other part of the answer is that we are only talking about operational energy here. There is enormous demand for green electricity for manufacturing and hard to abate regions of the industry, for example, materials manufacturing. We will need huge push for renewables. So the more we produce right now will eventually be helpful for that as well. And there is more to talk about, but I think that's probably sufficient for now.
Thank you. Another question for you, Aysu, just about your research and your modelling calculations. Both of you touched on, I guess, the risks that we're going to have increasingly common and severe natural disasters, particularly in Australia. Does your modelling take into account, I guess, the devastation and the waste produced by those natural disasters?
So calculating embodied carbon has several different methods, and inventory methods also, and as known, LCA, life cycle analysis, looking at various stages of the life cycle of a building. Depending on the database that is used, the inventory that's been undertaken, and the method that is used to calculate embodied carbon, demolition emissions can be a part of embodied carbon calculations. In such cases as, natural disasters, it's important to acknowledge what happens in the deconstruction and demolition and beyond life, including waste stages of a building, and engage with a consultant that can measure that impact and take that as part of the embodied carbon calculations. That should also probably touch upon policies or procedures that should factor this in a way that, in case of this kind of natural disasters and unexpected circumstances, there should be a pathway that to be followed in order to have these aspects factored in the calculations.
Thanks, Aysu. I'm conscious of the time, so maybe just one last question. With respect to, an amazing example like the Narara Eco-Village, do you think it's possible to create that on a much larger scale? For example, in a whole suburb or in apartments? And if so, how soon?
Yeah, absolutely possible, and it's already being implemented. Certainly internationally, there are examples. In Australia also, we have examples. Lockhill Valley comes to mind. There are many other examples where entire suburbs are being developed. And internationally, cities have been planned, or smaller townships. Auroville community in southern India comes to mind. And there are many global eco-villages. There is, in fact, a whole international eco-village network that works together. So scale is important, but scale doesn't have to be a monolithic scale. We can have a much more disintegrated scale to work together.
Wonderful. Thank you so much. So thank you to both of you for those fantastic presentations, and thank you everybody for joining us today. Just a reminder that these lean-ins are recorded to view later, and you can get notifications on when new lean-ins are available to view by subscribing to the Australian Institute of Architects YouTube channel, YouTube @AusArchitects. Thank you, everybody.
Thank you, Stephanie.
Thank you.